Unit 10, 9 station review, video, solutions video 3. I omitted station 5 from the 9 station review because it covered material that I'm not going to test you on. So let's go to single replacement reactions now. Zinc metal is placed in the solution of hydrochloric acid. Write the balanced equation for the reaction. Very simple. All you do is you write it out. Zinc metal, that's solid, plus HCl, hydrochloric acid, which is aqueous. What happens? Single replacement happens. Zinc switches out with the hydrogen. You form zinc metal. This is the part that might throw you. Zinc forms a +2. Okay, so zinc chloride, ZnCl2, plus H2 gas. Alright, H2 gas. And zinc chloride is going to be, if I'm not mistaken, it's aqueous, but let's double check. Zinc chloride is aqueous. I can run this reaction for you. I should actually run it for you so you guys can see this. You don't need to worry about what's oxidized. I should have crossed that off. I missed it. Okay, you don't need to worry about that. Aluminum metal is placed in a solution of ferric nitrate. Interesting. Let me zoom in a little bit. Aluminum metal placed in a solution of ferric nitrate. Alright. So that's going to be Al plus ferric is really just copper 3. No, yes, copper, I'm sorry, iron 3. Okay, iron 3 is ferric. So let's write these out. Al Fe3 plus, and nitrate is NO3 minus. There's your ions, okay? So ferric nitrate, FeNO3 3. And there's 3 of them. Okay, what happens? These guys switch. That's what happens. Okay, you end up with aluminum nitrate, which I've never heard of, but I guess it could happen maybe. Aluminum, whenever it forms its ion, again, aluminum in an ion form forms a +3. So it's going to be Al NO3 3 plus Fe plus Fe. Okay, plus Fe. I'm not sure that this actually happens. Maybe it does. Anyway, you don't need to worry about this. Let's go ahead and say this is solid. This is a solution, so it's aqueous. That's now solid. And let's see what happens here. AlNO3. Okay. Aluminum. Where are you? There you are. Aluminum nitrate, aqueous. Aqueous. That's done. That was station number 6. Okie dokie, let's do the next one. Station 7, more single replacement. Nickel metal is placed in a solution of cupric chloride. So nickel, whenever it forms an ion, forms a +2. And cupric chloride is just a fancy way of saying copper 2. Okay, that's cupric, copper 2 chloride. So you got Cu2 plus, and chloride forms a -1. Alright, write the balanced reaction. So nickel metal. Notice whenever I write it in solid form, I don't write the charge with it because it's not an ionic form. It's not an ion, it's a solid at that point. Okay, so don't write that. Don't make the mistake of writing that up there. They're telling you it's solid. That means it's not an ionic form. Alright, copper chloride, copper 2 chloride looks like this. CuCl2. Okay, what happens? These guys switch. So now you got nickel. Now it is ionic. Nickel 2 is +2. So NiCl2. Plus, what happens to the copper? It forms a solid. Okay? It forms a solid. So it's no longer, the charge is not written there once that thing forms a solid. Okay? So don't worry about that. You can cross this off. Yeah, this is a solution, so it's aqueous. Now we got to see if nickel chloride remains aqueous, which it should. Let's see. Nickel chloride aqueous. Okay. Nickel chloride aqueous. Alrighty. Calcium metal is placed in a solution of hydrochloric acid. Calcium metal. Okay, so calcium, whenever it's in its metal form, is just Ca solid plus HCl, which is hydrochloric acid, which is aqueous. Okay. What happens? The acid eats away at this, and you form calcium chloride. Okay, these two switch. CaCl2 plus H2 gas. Okay, how do I know that? I just do. All right, I just do. That's what happens when you put metal in an acid. It releases hydrogen gas. All right, so that's all you need to know about that. Calcium chloride. Here we go. Calcium chloride is aqueous. Aqueous. All right, and there you have that. Yeah, if calcium switches with hydrogen, you cannot write hydrogen by itself. Okay, you can't just write H plus because it's diatomic. You have to write H2. Oh, we forgot to balance, didn't we? We'll get to that in just a second. Yeah, it's H2. And anytime you have H2, H2 is a gas. It never forms H2 solid. It's a gas. Okay? So let's balance this as well. So let's put a 2 there. And up here, we forgot to balance, but we don't need to. Okay, we're good there. All right. So that's station number 7. Okay, station 8. I should have crossed this off. I'll just cross this one off for right now. Okay. I'm not going to get into why. Just we'll cross it off. In an empty container, 32 grams of C3H8 and 35.2 grams of O2 are added. Find the moles of each gas. So it's very simple. All you have to do is this. 35.2 grams C3H8 over 1. There's your molar mass of C3H8. 44.09 grams per 1 mole. Okay, I'll do the math here in a second. Let me go ahead and set up the other one. 35.2 grams O2 over 1, and molar mass of O2 grams per mole, 32.00. Okay, 35.2 divided by 44.09 gives you a total of 0.798 moles. C3H8, and 35.2 divided by 32 is going to be about a mole, but we'll go ahead and do that anyway. 1.1 moles of O2. What volume at STP of CO2 will be produced at the end of the reaction? The reason I crossed it off is one of these two is going to limit how much CO2 can be produced. And initially you're going to think it's that one, but it may not be. It might be the amount of O2. So the only way to really find out is to know which one limits, and to be honest with you, that's going beyond the scope of this unit. Okay, I can teach you how to do that, but I'm not going to. Well, we'll just leave it at that. That's why I crossed this off. Some of you might have done this. You might have taken one of these two and run the reaction. You might have gone like this. You might have said 0.798. Here's how you would do it. If we found out that we're going to use this number here, so 0.798 moles of C3H8, 1, and then you look at the mole to mole ratio. 1 mole of C3H8 to 5 moles of, to 3 moles of CO2. What volume at STP equals 0.798 times 3. Two point 2.394 over 1, and then you could go 22.4 liters per mole. Okay, you could do that. But the point I'm trying to make is that how do you know which one to use? Well, there is a way to tell, but I haven't taught that to you, and I'm not going to teach that to you. So what I would do on a test is I would give you one of the two and just say, using 35.2 grams of C3H8, how many moles of CO2 will be produced, or how many liters of CO2 would be produced? Okay. Anyway, let's finish this problem. Times 22.4. And this will tell you how many liters is produced. 53.62. 62 liters of CO2 was produced using 35.2 grams of C3H8. How do you figure out how much is really produced? Well, you have to run both of these reactions and see which one produces less. Okay? And the one that produces less is going to be your correct answer. Because it's like saying you can only make one pizza with 3 cups of cheese. Okay, and if you have 8 cups of cheese, how many pizzas can you make? Well, you can only make 2 pizzas because you don't have that 3rd cup for the 3rd pizza, right? Anyway, that's kind of the idea. I'll go ahead and do one last video.